4.2 is about engineering notation. To express the numbers in engineering notation, the way is very similar to express a number in scientific notation. It just has different rules. There are three rules for expressing a number in engineering notation. First, the number can be either positive or negative number. It cannot be zero. The second rule, the absolute value of the number is between 1 and 1,000. It can be greater than or equal to 1 and has to be less than 1,000, which means it cannot equal to 1,000. It can be 999.9999, but just cannot equal to or greater than 1,000. The third rule, it multiplies by a power of 10, but the exponent need to be multiple of 3. That means the exponent can be 3, since 3 is 1 times 3, it is multiple of 3. It can be 6, since 6 equals to 2 times 3. It can be 9, 9 is 3 times 3. It can be 12, 12 is 4 times 3. It's okay to be negative 12, negative 15, negative 3, negative 9, negative 6, as long as the exponent is multiple of 3. An exponent that is not multiple of 3 is 2, or 5, 7, 11, 22. These numbers are not multiple of 3. Let's take a look at this number, 342.1. Is this number in engineering notation? Let's check. So the absolute value of this number, 342.1, is greater than or equal to 1 and less than 1,000. And now let's check its exponent. The exponent is 3. 3 is multiple of 3. So this number meets all three rules. Therefore, this number is expressed in engineering notation. How about let's try this number. Negative 53.7 multiplied 10 to the power 6. The absolute value of this number is positive 53.7, and it's in the range. It's greater than or equal to 1 and less than 1,000. For the exponent, it equals to 6. 6 is multiple of 3. So this number is also expressed in engineering notation. How about let's try this number. 248.1 multiplies 10 to the power 5. The absolute value is 248.1. It meets root number 2. It's between 1 and 1,000. However, the exponent is 5, and 5 is not multiple of 3. So this number is not expressed in engineering notation, only because of the exponent. However, we can convert this number so the result can still be expressed in engineering notation. Now let's take a look at this example. We want to convert 248.1 multiplies 10 to the power 5 in engineering notation. First, let's write down the number. Let's look at the exponent. The original number has an exponent of 5. If we add a 1 to the 5, it becomes 6, and the 6 is multiple of 3. So here is the clue to convert it. Just by adding a 1 to the exponent is a multiple of 3. If we add a 1, which means we multiply a 10, we add a 1 to the exponent, we need to do the opposite for the number part. We need to divide that 248.1 by 10. Divided by 10 means move the decimal point to the left, 1 unit. So at the end is 24.81 times 10 to the power 6. So 24.81 multiplied 10 to the power 6 is correctly expressed in engineering notation. Now let's work on these three more numbers. For A, it is 0.03 ampere. We want to convert it to equivalent engineering notation. Put the number down, 0.03A. The absolute value of it is outside the range. It's less than 1. We need to move the decimal point to the right in order to make the number falling in the range. That range is between 1 and 1,000. The question is how many times we need to move the decimal point. If we move the decimal point to the right twice, it becomes 3. Since we move the decimal point to the right twice, we need to do the opposite for exponent. The exponent need to subtract 2. 0 minus 2 is negative 2 and is not multiple of 3. So that implies we shouldn't move the decimal point to the right twice. How about let's move it 3 times. If we move the decimal point to the right 3 times, the exponent need to subtract 3. That becomes negative 3, and the negative 3 is multiple of 3. Therefore, we should move the decimal point to the right 3 times. After moving it to the right 3 times, 0.03 becomes 30.0. The exponent becomes negative 3. So the answer is 30.0 multiplies 10 to the power negative 3 ampere. Let's take a look at the second number, 5415.14 volt. We want to express the number in equivalent engineering notation. For a number expressed in engineering notation, the exponent needs to be multiple of 3. 5415.14 volt is 5415.14 times 10 to the power 0. We need to tweak the exponent so it's multiple of 3. The 5415.14 obviously is greater than 1,000, so we need to shrink this number. By moving the decimal point to the left, the question is how many times? How many times we need to move this decimal point depends on the exponent. Exponent need to be multiple of 3. So how about let's move it to the left 3 times. Since we move it to the left 3 times, shrinking the number, we need to do the opposite for the exponent. Add a 3 to the exponent. So at the end, the answer is 5.41514 times 10 to the power 3 volt. This number is expressed in engineering notation. Here has another example, is 20 million ohm. We want to express this number in equivalent engineering notation. First, let's copy down this number. This number, 20 million, obviously is greater than 1,000, is outside the range. We need to shrink these numbers. The number of times that we need to move the decimal point depends on the exponent. For the current exponent, it's 0. If we move the decimal point to the left 6 times, this 20 million reduced to 20. Because we move the decimal point to the left 6 times, we do the opposite operation for the exponent, add a 6 to it. So at the end, the answer is 20.00 times 10 to the power 6 ohm. For this course, unless additionally specified, we just keep 2 digits after the decimal point.